Good afternoon. Today we're going to look at player stats and collecting resources in the game. So let's go ahead and get to it. I'll go ahead and show here. I have a tree resource for wood, a little berry bush for trees, and a little rock resource. The stone resource I made 2 classes ago is just a static mesh. The berry bush I made as a blueprint. So I'll go ahead and show it real quick here. Blueprints. Resources. It's just a set of circles um, and individual berries all smushed together into a berry bush. The wood, there should actually be a wood texture to that. Let me fix that real quick. Materials. There we go. Didn't see it because the berry bush sits pretty close to the ground. And then for the trees, similar concept. Resources, the trees, I just took some cylinders or cones and put them on top of a cylinder and went ahead and colored them up. I have a single master material and a bunch of material instances to color the different parts. The rock is just a static mesh, same thing. The blueprints for the resources inherit from the blueprint base resource, which comes from C++. Each resource on the side there, it has a resource type that is an enum that you can do the pull down for. When you gather a specific amount, and then there's a resource total, and that's per item. So for the berry bush, it's berries. Gather amount should be 1 by default, and then resource total is 6. The berry bush in the world already had it set to 1, so the gather amount was correct for that one. All right, when you hit play, you have your hunger ticking down on the top left. As soon as it hits 0, it ticks down by 1. And as soon as it hits 0, your hunger starts ticking down by 5s. I went ahead and set the hunger at 5 to start, just so we could see the life ticking down right away. As well, in the bottom left corner, you have the wood, stones, and berries widget. When you come up, so the tree had 30 wood, and you collect 5 at a time. When you get close to them, you can see that little F to interact pops up. Press F. You can see we incremented by 5 in the top corner, and if you do this 5 more times for a total of 30 wood, the tree will be destroyed. Same thing for the berry. The berry had 6 berries, and you picked 1 at a time. So we'll go ahead and 6 pick berry. You can see it's incrementing in the bottom left. And then for the rock, it has 30, and you increment 5 at a time. All right, all 3 resources were destroyed. All right, so how did we implement this? So I'm using delegates with bind on events for the UI. So let's go ahead and look at the HUD. Okay, so we have our life, which is 3 separate widget blueprints, and then we have our resources, which is a single blueprint, our widget blueprint. When we come up here, I do a sequence, set the character. What I do is I set the initial health when you first load, and then I go ahead and bind on a delegate from C++ to update the percent, and I also put text overlaying the bar as well. I'm not sure if you saw that, but you can see the life has text over top the red, green, and blue bar, and that updates every time the timer in C++ ticks over. So that's it for Unreal Engine. Let's pop over and look at the code in the background. Um, Okay, so the code in the background. Started off, I have resource types as an enum, and this is a single header file that is in multiple files to provide the same enum values. That way you don't have to recreate it in the header of each file. We have type invalid, which is the default, and then wood, stone, berries, and then this count is a hidden one that's used for this enum range by count, which is then used later on to build our map for the resources. So let's go ahead and look at the resource base. This is the tree, the rock, and the berry bush. Okay, so you have your header. We have our base. I go ahead and set up the from the resource types, which is linked to the top here. I link our resource types, and I go ahead and give us an enum in here called resource type. Initial gather amount, and then our initial resource total. These are just part of the construction So they can be changed in the engine to be whatever the developer wants it to be. This just provides us default values in case they're not changed. We have our resource mesh, which is then changed to the tree, the rock, or the berry bush. And then we have a function for decrement amount. Okay, when we look over at our C++, okay, so we go ahead and set our default mesh as a uStatic mesh component, not uStatic mesh. A lot of people make that mistake. And then we call it resource mesh, and we set it as the root component. Decrement amount, I look at what is our current amount minus the gather amount and reassign it back to resource total. If the resource total is less than or equal to 0, then I go ahead and destroy the actor. Super simple, and that's it. For all the meshes share the same basic code, and they're all just children based upon that. Okay, let's look at our, we already looked at resource types. Let's look at our player character. Okay, because we had to add stats. So I have a series, 3 delegates. I have on health update, on stamina update, and on hunger update delegates. Okay, I add our resource component, which we'll look here at the end. That is attached to the character, and that basically stores all of the character's resources. I added a input action for interact action. Going down, let's see. What else changed in here? Okay, so I have our health stats, float. They're categorized under the stats category. I have our max health. So you have a health and a max health that lets you get percents of health. Let's say a character levels up and their health is no longer 100, then having a static divide by 100, which some people like to do, doesn't work. You have to know what the new max value is and divide their current health by whatever the new max value is. It's not always going to be 100. Also, same for the stamina. This also lets it so if you heal back up, you don't go greater than max health. We have some clamp values later on. I'll show you that one. And hunger. This is how fast you. So I set it at 5 initially, just so we can see the demonstration that after it hits 0, then the health starts ticking down. But normally it would be 100, and then the max health of 100. Here's the delegate definitions. So we have our on health updated, on stamina updated, and on hunger updated based upon the delegate definitions that we created up top. All right, added a function for interact, set health, set stamina, set hunger, and decrement stats loop. The reason I did it as that naming convention because we're decrementing the stats, and it's part of the main game loop that as long as the game is playing, it is constantly decrementing those values. So it's essentially a part of the game loop itself. Okay, that should be it. Let's look at C++. All right, all at the top. Okay, our basic camera component, nothing changed here. I added our resource component as a resource component. I like to, let's look at the .h again. At the top, I like to forward declare my class values and then do the adds here at the top for the different classes. So we go ahead and add our uResource component, and we call it resource component, which when you saw on the player, we'll peek over here again real quick. Look at the player component. We look down at the bottom and we have resource component, which has 3 mapped resources, wood, stone, and berries of 0, 0, and 0. We'll see how that got set to 0 later on because that's not a value that I set. The code sets that itself. All right. We come down. We set a timer, and this is going to be our decrement stats loop every 1 second using the stats timer handle, which we created up here. So the stats timer handle is calling the decrement stats loop every 1 second. Here we have a tick. I just have this set up so that way I know I don't like using tick, but if the player looks at something that could be interacted with, then there has to be something under tick constantly checking to see what is the player actually looking at. So in general, I do not use tick. However, for this one particular purpose, there is no way to get around it for what the character is actually looking at. Coming down here, I added the bind action for the interaction component, added it to the character. What else changed? Okay, setting the health. So the health is using the fmath library, and I'm clamping it between the health plus whatever value change. So this is if the value changes, whatever plus the value change. It cannot be less than 0 and it cannot be greater than max health. So if you were at 99 and you got plus 5 health, it would cap out at 100 and return 100 as the health value. If you were at 2 health and you took 5 damage due to hunger, you would not go to -3. It would clamp it at 0 and assign 0 to 100 into the health value. Once that's changed, then I go ahead and call my delegate, and I'm passing as a percent, so health divided by max health. And when you look at the definition of the delegate, it actually says health percent. So when you see it in the game as the character, when you look at the HUD, it says health percent right here. So you know you're dealing with the percent. That makes it real easy to go ahead and just set the percent of the progress bar. If we need to be something other than that, we can always go back in and redefine the delegate from there. But just made it simpler on what I had to do in blueprints for the widget interface. So we passed the health percent on that. Okay, same thing for stamina. Clamp it between 0 and the max stamina value and return it back to stamina. So basically it takes the current value plus the input value and then clamps between the two. Then we go ahead and broadcast that one as a percentage, stamina divided by max stamina. And then we do the exact same thing for hunger. Since they're all doing essentially the same thing, I could actually make an enum for health, stamina, and hunger, and then map it out or make an array. A map would probably be better. That way you have health to value mapping instead of an array where you have to have tracking the values yourself. And then basically I would just need a single function to do that, but for now, this meets the requirements. And then decrement stats loop, so always, while this is looping, every 1 second, we'll get -1 hunger, and I set stamina to increase by 5, but it is clamped up from 0 to 100, and then if the hunger is less than 0, then it goes ahead and starts decrementing our health by -5. I have just an on-screen debug message that printed out the health, the hunger, and the stamina until I was able to get the widget um, up and running to show the health bars, the progress bars. Okay, interact. So for here, I use a line trace by channel to see if the hit object is an interactable object. I think that might be spelled wrong, but there is no better spelling recommendation. Okay, we go ahead and define our hit result, which is our out. Uh, um, what is it? It's an out value as a, or out parameter. So basically, it takes all the information and returns it back to this parameter here as an out value, and it also returns a true/false, which we define as b hit. We define our starting location as the center of the camera. Our end location is the start location plus the forward vector times 1,000, so 1,000 units forward of the camera added to the start location is our end location. For collision parameters, I'm just ignoring ourselves. That's all we need to do for now. And then I return it, was something actually hit or not. I have a debug line. It's just right here, setting the color, where if B hits true, then it's going to return a debug line that's red, and if it doesn't hit anything, it's going to return a debug line that's green, using the ternary operator here. I draw my debug line exact same way as doing the trace line right here. Except you can set colors and how long it's visible for. That's the only big difference. Once I was able to get the user interface for incrementing and incrementing the user interface for the different resources, I no longer needed the debug to see if I was hitting the object because I could see because the widget would increment. Um, Once we get a good line trace, we look. So was there a good line trace? We go ahead and store that as the hit actor, and then we want to know it was the hit actor, specifically a resource actor. And my resource base is the base actor for all of my resources, so we're calling it actor resource base or a resource base. And then we just do a quick cast to this. If it was a resource actor, then we go ahead and go down and we get the resource type, and we get the gather amount from that particular resource. So if it gives us 5 each collection, then we get back that we got 5 and what type of resource did we actually do the line trace on. So if we hit a piece of wood, it'll say I am a piece of wood and you get 5 at a time. And then what we go ahead and do is we go to our resource actor and we go ahead and decrement their values. Uh, as we saw earlier, the decrement function. And then we go to our resource component, which we're going to look at in a minute here on the character, and we add to resource function where we pass in the type of resource to add and the amount that we gathered from there. I was also printing out, this is another on-screen debug message where I was getting the name of the hit actor when I was doing it just so I knew what I was hitting if I was actually hitting anything. It's still in here just in case I ever need to bring it back up for debugging purposes. Another thing, debug, when you do your package build, the debug stuff does not actually go into the final build by default. So it's actually not a bad thing to keep it up and available if you wanted to, but I went ahead and took it out because I don't like cluttering up the screen. Okay, and that's it for the player character. Pretty simple for stats and the resource component. Now, how are the resources added to the player and how are they tracked? That's inside the resources component. So what we'll do is we'll come up, take a look here. We're linking again to the resources types enum header file. That is just a header file just for the enum. And we go ahead and pass out a dynamic declaration of called on resource updated. And that passes back the resource type and the quantity. And this is so that the widget can bind to the on resource updated delegate and knows which type of resource to increment and by how much. Let's see, looking down here. Okay, so I make my T map. It's basically just the resource type from the enum and a integer value, and I go ahead and call that resource map. I have a U function here for adding resource type. So if you want to add new types of resources from the Unreal Engine itself, instead of having to come back here into the code, let's say the player picks up iron. It can add a new resource type, and then it'll set the default value for that when it's added. Also, get resource amount. Let's say you want to know how much stone do you have. This is a function that's actually used to set the initial values inside the user interface. And then add to resource. Let's say you want to increment the resource. All we're doing is we're taking the resource type and the amount that we want to add, and we go ahead and make a function for that one. I set a max resources of 100 here. We can go ahead, edit, if I could type, anywhere. Okay, and we'll go ahead and make blueprint read write. So that way, if the designers want to change the max resource type, let's say you have a new upgraded inventory bag or a new upgraded crafting bag that holds resources, you could then change the max resource value to hold more resources. Otherwise, when we do our add to resource, it's going to clamp it between 0 and because if you're crafting and you're using up resources, you can't go below 0 and whatever the max value is here. That way, a player can't just go and start gathering trees and get infinite number of trees. We put a max resource on there that a player has to actually unlock whatever the max resource new value would be. And then we call our delegate here on resource updated. Pretty simple. So let's go ahead and take a look at the C++ code. All right. Okay, we go ahead and go through and we set all of our, we run a loop here, a for loop setting other than invalid. So for the first one was invalid, but for the wood, stone, and berries, so if it's not invalid, then we set it the default resource value to 0. And that's how on the character the values were initially set to 0. So if a new character is created, those values would also be created at or set at 0 for that new character. The resource type, when we want to add a resource, it will get, if it checks to see does the resource map contain that resource type. If not, then it's going to add to the map that resource type with a amount of 0. Get resource amount, all we're doing is we're just setting quantity as our integer value, and then we're checking is that resource type in the resource map. If yes, return the quantity for that value there. And so another ternary there. So quantity will either return the quantity or 0. and it's a pointer to the quantity here. We don't actually need to actually send the actual quantity itself. Okay, then finally the add to resource. So if the resource type is contained within the map, that then it knows to not add in. I guess you could do an else add, but add to resource. If it contains it in the resource map, then we go to the uh, resource type for the resource map and we clamp it between the existing amount and the added amount that we want to get, and we clamp it between 0 and whatever the max resource value is. After we go ahead and do that, reassign it back to the resource map resource type, which is the value quantity for that resource type. Then we go ahead and call our delegate, and we're passing the type and the quantity. That's it for that. So all that sets up everything that we saw in here. So go ahead and hit play one more time. You got your widget in the bottom, you got your stats in the top. Collect 6 pieces or 6 times from this, it's destroyed, and you got your 30 wood. 6 times from this, you got your 6 berries, and your 6 times from this, and you got your the stone has been destroyed. All right, and then I'll have to work that F interact where when object's destroyed, it's going to remove that widget. But yeah, all the widgets are just bonus. That's it. I believe that covers. Looking here at the list of requirements. Let's see, there were comments in the code. We talked through everything in the code. Repository. So let's look at the repository. So as I've added one, so I did my stats, merged it. I created my pickups, merged it, and then I added my line trace and user interact, and then merged it. And you can see in each one, when you click on them, it actually goes a little bit more in depth on to exactly what was done on each one. Okay, so that was our commits, and it says got to show the source. So here's the source. I think that about covers it. Yep, nothing else left on the stepping stone module to stepping stone. All right. Thank you for watching.